All right, this is integration by parts with a definite integral. So you can see this is our formula. And the first one was already evaluated, right? So, or the integral was taken, and now we can evaluate it with b and a. And then the second part still needs to be finished. So let's try one. Our first one here, this is u. And then our next part would be dv, because the u of the x gets simpler as we move through it. So that means dv would be cosine pi x dx. So v integrated would be sine, we'll put a 1 over pi in front, pi x. And then we always check the derivative. So sine of pi x would be cosine pi x, perfect, times the pi x, which would be pi, cancels 1 over pi, works perfectly. All right, so those two go first. So I'm going to put x over pi, and then sine pi x, and put our line, and now we can put our 1/2 and 0. Minus, and then the integral 0 to 1/2. And we do our bottom ones, and that's our minus. So that would become minus, good. 1 over pi can go outside, and then we have sine pi x dx. All right, so now we just need to integrate that one. So minus 1 over pi times 1 over pi cosine x. So since we're dealing with cosine, that changes back to a plus, and then we'll check it. So that would become sine pi x with a negative, perfect, and then times a pi, which cancels with that pi, leaving us with just 1 over pi, which is what we want. So 1/2 to 0. And this is what I was talking about, or haven't talked about. But if you're dealing with x all the way through, you have not changed it to u, then we can just use it as one giant one like that. We can even factor out the 1 over pi if we want and go from there. But I'm going to leave it in. So this would be 1 over 2 pi sine of pi over 2 plus 1 over pi squared cosine pi over 2. And then the next one would be minus. If we plug 0 into the first, it doesn't matter because that's a 0, so it's gone. Minus 1 over pi squared. But cosine of 0 is 1, so we will actually have to figure that one out. Okay. So sine of pi over 2 is 1, so we get 1 over 2 pi. Cosine of pi over 2, though, is 0. And that's just 0, so I'm not going to even rewrite it. And then cosine of 0 is 1, so minus 1 over pi squared. So we end up with 1 over 2 pi minus 1 over pi squared. That is our definite integral. Now, all we have to do is check it in our calculator. You always check these. So if we input the integral in, so our math 9, 0 to 1/2, and then x cosine pi x dx. Make sure your mode is in radians. All right, so we're good. We got that. So we should end up with that decimal. So now if we enter this fraction in, 1 divided by parenthesis 2 pi, and I could have used alpha to get there. Exact same answer. So we're good. There's our answer. All right. Now let's try it with the tabular method. So we did one now with this, but what if you're using the tabular method? Because you don't want to have to do integration by parts with something like a t to the 5 or something. So if we use the tabular method, it's the same thing that we just did here, how we plugged it in at the end, but we're going to write out the entire integral and then plug it in. Okay. So our u is obviously the t squared. So that would be 2t and t. So integration by parts, oops, and 2. Integration by parts twice. And then our dv is our e to the t dt. So that would just be e to the t, e to the t. All right, so first one's positive, negative, positive. All right. I'm going to put a negative on there just so we have it. All right, so we end up with t squared e to the t minus 2t e to the t plus integral 2 e to the t dt, and this is from 0 to 4, and these are from 4 and 0. So just so we have the notation. So the next one would be 2 e to the t, that's our integral, plus minus 2t e to the t, t squared e to the t, 40. Now, I don't want to plug in e to the t each time. That's going to be a lot. So e to the t, and then t squared minus 2t plus 2, 40. All right, so we're going to do one with 4 and then one with 0. So with 4, we would get e to the 4th, 4 squared minus 2 to the 4th times 4 plus 2 minus, and then now the 0. So e to the 0 and then 0 squared. See, it looks just a lot nicer, right? It's more compact. Minus 2 times 0 plus 2. All right, so this one would obviously be 1 times 2. And then this is e to the 4th. And then now we just have to multiply that out. So 16 minus 8 is 8, plus 2 is 10. So we have 10 e to the 4th minus 2. And you could factor that some more if you really want. You could say 2, 5 e to the 4th minus 1. It's your choice. But what we need to do now is check it with our calculator. So let me clear that one out of there. Math 9. And we're going from 0 to 4. X squared, second e to the x. Remember, you can pick any letter you want. It means the same thing. All right. So our answer should be 543. So we should see 10 e to the 4th minus 2 as the same thing. Look at that. Perfection. So we know we did it correctly. No simple errors in there, because I make simple errors a lot. I'm focusing on the problems themselves. It's kind of hard to see all of them. But there you have it. So the whole idea is make sure that when you plug these numbers in, you're plugging them in for the variable that that integral represents. So if you do have to use u substitution on the second part, then you're going to have to plug half and 0 into this one, and then whatever letters you have here. Or you convert it all back to x's at the very end, and then plug the numbers in. That's what I like to do. So I would always just plug them into the same letter at the very, very end.